A copper rod 8 mm in diameter, when subjected to a pull of 960 newtons, extended by 0.16 mm over a gauge length of 450 mm. Find the modulus of elasticity of copper. Find the modulus of elasticity of copper. So first of all, here there is a copper rod. There is a copper rod, okay na? So and diameter is given. Diameter of copper rod D is equal to 8 mm and subjected to a pull off. So this is okay na? So this copper rod is subjected to a pull of 960 newton. 960 newton. So F is equals to force. So here load or force is equals to 960 newton. So due to this pull of 960 newtons, so the generally the rod elongated, okay, along the direction of force. So here extension is delta L, change in length is given. So here change in length. So change in length, delta L is equal to how much? Generally denoted by delta L. Delta L length వచ్చింది మనకి 0.16 mm. Okay na? And also gauge length. So actual length of the bar. Gauge length means actual length or original length of the bar or rod. Original length of the rod denoted by L. L means gauge length or original length. How much is given? 450. 450 mm ichchadu question. So let us write all the data here. So here force or load is equal to 960 newton and diameter of the bar, diameter of rod. Diameter of rod D is equal to 8 mm and gauge length or original length, gauge length or original length, gauge length or original length L is equals to 450 mm. Okay, so here we need to find modulus of elasticity. So మనం ఇక్కడ modulus of elasticity find out చేయాలి. Here we need modulus of elasticity denoted by capital E is equal to what? We know that according to Hooke's law, so in stress strain relations, Young's modulus or modulus of elasticity E is equals to stress by strain. Here formula is stress by strain. So stress denoted by sigma, strain denoted by epsilon. So stress is equals to here. So stress here stress sigma is equals to resistance force by area. So resistance force denoted by capital F by area denoted by capital A. So in general, resistance force is also known as load by area. Simply we call it as load by area. Stress is equals to load by area. So here sigma is equals to, so load nothing but force. How much force applied here? Here applied 960 newtons force applied. Okay, next area. So we know that area of rod A is equals to pi by 4 into d square, where d is diameter of the rod. So diameter of the rod ఎంత ఇచ్చాడు మనకి? pi by 4 into, yeah, diameter of the rod is 8 mm, so 8 square. So mm square, okay na, 8 mm, so mm into mm square. The sigma is equals to 960 by pi by 4 into 8 square value 64. So units Newton per mm square. Stress units Newton per mm square. 1 Newton per mm square is equals to 1 MPa. Okay. So let us calculate this. Sigma is equals to reciprocal of pi by 4, 4 by 5. So 4 into 960 by pi into 64. We know that 4 ones and 4 16s, 64. And 16 ones and 16 60s. 960. So 60 by pi Newton per mm square. Okay, so we know that strain is equals to so here strain body subjected to longitudinal strain because we applied force along the length of the rod. So strain is equals to So change in length, longitudinal strain is equals to change in length by original length. Change in length by, here strain is longitudinal strain, change in length by original length or gauge length. Change in length by original length or gauge length. So change in length is delta L, original length is capital L. So epsilon L is equal to, here change in length how much given, 0.16 mm, and original length of the bar. So here original length of the bar is 450 mm. Original length of the bar is 450 mm. So mm get cancelled and 0.16 by 450. So let us find value of 0.16 by 150. 0.16 divided by 450. So we got approximately 3.56 into 10 to the power of minus 4. Now using stress and strain values. So here we have stress value and here we have strain value. We know that Young's modulus is equals to modulus of velocity is equal to stress by strain. So substitute the values. Stress is 60 by pi by strain 3.56 into 10 to the power of minus 4. So now let us calculate the value. So 60 by pi, 60 divided by pi whole divided by 3.56 into 10 to the power of minus 4. So here we get the value as 53647.73 Newton per mm square. Here strain has no units, so anyhow stress unit is Newton per mm square. You will get Young's modulus or 53647.73 Newton per mm square, or so it can also be written as a Young's modulus E is equals to, let us move this point for three places, 1, 2, 3. So it can be written as 53 point approximately 65 into 10 cube Newton per mm square. We know that 10 cube Newton per mm square, 10 cube MPa can be written as GPa. So E is equals to 53.65 GPa, gigapascals. This is the Young's modulus of the given rod. So 53.65 gigapascals. Okay.